Welcome to Module 5, Lesson 3. So, just quickly, the audio right now probably sounds a little echoey as I'm kind of far off in the distance. I've been trying to mess around with some settings. It's just not getting to work right now. Hopefully, I'll have this fixed by the next time I do my recordings. But for right now, we're going to go on as if things are normal. Apologize for it, but we'll jump straight into it. So, we've been talking about fractions, and now we're going to be moving into another realm of fractions. Really, not really a new realm, it's just identifying them ourselves and kind of making ourselves. Anyways, what I mean by that is that I want to figure out if I can specify and partition a whole into equal parts. So, before, we have had shapes and images given to us, and we've just used division. So, like, as an example, I would have a tape diagram. I would say I have a total of 20 here. I have 4 groups. How many would go into each group? 20 divided by 4 would equal 5. So this would be 5, 5, 5, and 5. So we're doing a very similar thing to this right now. Instead of working in those larger numbers, we're going to be using the words partition, equal parts, and whole. So, when I draw a picture in a fraction, I'm representing a whole, like a whole piece of like pie, a whole turkey for Thanksgiving, a whole like pizza, basically a whole Snickers bar, a whole Hershey's bar. You get a whole bag of Skittles. You kind of get the idea. But it's usually one big solid piece that's completely by itself. Just kind of keep that in mind. So I'm going to use a Hershey's bar for this example here. So I have a whole Hershey's bar. And I can partition this Hershey's bar into smaller pieces. And I'm using that word partition. Partition is basically doing the same thing as in making those groups. But instead of saying that I have 5 whole pieces in that group, that piece represents less than 1. So this is 1 chocolate bar. If I was to draw a line right here, assuming I've drawn it perfectly in the middle, and so that both parts, each piece can be used as a word part, so both parts are equal to each other. Now this is 1 of 2 pieces, and we've represented that as 1 over 2. So how many pieces does it take to make a whole? It takes 1, 2 pieces to make a whole. Now let's say I have a identical chocolate bar right next to it. I've cut it up into 4 equal parts. Now 1 piece of that would be 1/4, or 1/4 of the pieces. Now, once again, I've mentioned this before, but the terminology fourth, this isn't 1/4 or 1/2. This is a half, and this is 1/4. And I can continue this on. If I had another chocolate bar and I cut it into, let's just see what I get, 1, 2, 3, 4, 5 equal parts, this would be 1 over 5, or 1/5. Pardon the board shaking. Or 1/5. And if you have more than that, if you fill in 2 of these, this would become 2/4, so on and so forth. Hopefully you get an idea of that. Now, the idea here is that you, yourself, can look at something and determine how many parts that's cut into. And the hardest part about this is just remembering that, like, 4th, 3rd, 5th, 6th, 7th, 8th. I'm doing that on purpose right now because it's not just 6. If we're dealing with fractions, it's 6ths. If we have 7 equal parts or equal portions, they're not 7, they're 7ths. So kind of keep that in mind. So, as an example, I have a whole piece of Hershey's chocolate bar here. I'm going to break it into 7 pieces. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. There you go. And assuming I have drawn this out perfectly and all parts are equal, this would be 1, 2, 3, 4, 5, 6, 7 to make 1 whole. So how many pieces does it take to make 1 whole? 7 pieces are needed to make 1 whole. Or I could ask you, what unit are we in on this? And the unit is, how many are there? So we're in 7. We're in the unit of sevenths. So if I have that same chocolate bar or an identical one here, I cut into, let's say, 5, 6, 7, 8 pieces, this would be eighths. Oops, I need to spell 8 correctly the first time. My goodness, my brain's having like a little bit of a problem right now. I legit just kind of forgot how to spell 8. Okay, I'm not crazy. Okay, I was spelling it right originally. My brain had a moment, but I'm back. So, eighths would be right there. I think having the H after the T in the word eighths was throwing me off there. I got it. I figured it out. So, eighths. And we have 1, 2, 3, 4, 5, 6, 7. There's 8 eighths. So, it takes 8 eighths to make one whole. Up here, it takes 7 sevenths to make one whole. Or I could say I fill in 1, 2, 3 of these. Now, how many sevenths do I have? I have 3 sevenths, or write that as 3 over 7. Down here, I could have 1, 2, 3, 4, 5, 6. I have 6 what? I have 6 eighths. So 6 eighths. And assuming that these are both the same chocolate pieces, we'll kind of do this real quick. Which is larger, 3 sevenths or 6 eighths? Well, they both start at the same point. 6 eighths gets farther. Now, I will actually change that to 5 eighths just to make this next example a little clearer. 5 eighths right there. Let's do the same type of chocolate bar cut into thirds. So 1, 2. So this would be thirds because we're in threes. So thirds. So I have 2 thirds here. If I draw that line all the way down, you can tell that this one's a little bit larger. So 2 thirds is actually bigger than 5 eighths. We'll go into that more on a later date. But today, it's primarily recognizing me drawing a picture, you being able to recognize, oh, that is this many pieces. Eighths, sevenths, ninths, thirds, fourths, fifths, etc. And that could be done in many different ways. We'll start off with a triangle. You can cut up a triangle, but if I were to cut the triangle like this, would those parts be equal? No, the bottom is going to be a lot bigger. So if I was to cut this equally, I could only do it one time, and it would be down the middle like that. Now, this would be in the halves. Now, you don't see twos. I don't say tooths, because that just sounds weird. I'm not talking about teeth. So tooths, instead of saying tooths, you say halves, because tooths sounds weird. They all sound weird, but the two one sounds especially weird. So this would be halves, because we are dealing with F. If something's cut into 2 equal pieces, you have half of it. So we just say halves. So if you saw that, you should be able to recognize and say, oh, that is halves. Now, I could draw another one, and I'm going to ask on this shape, are these pieces equal to each other? This piece might be equal to this one. This one might be equal to this one. But is this piece equal to this piece? No. Because of the fact that it's not a uniform shape, kind of, each piece gets a little bit different and a little bit farther off from each other. So you can't really use that as an example here. But let's try a shape like this. All right, let's try cutting this one up. Are all those are these equal parts? Is this the same size as this one? No. And if it doesn't match one of them, it doesn't work. This one might match this one, and this one might match this one, but they don't match all of themselves. They need to be all the same. So you can't split up that way, but this shape you actually can split up a couple of different ways. I'm going to go ahead and show you real quick. So I'm going to go ahead, cut across down that way, and cut across down that way. So now it looks like a kite. If I've drawn this perfectly, once again, human error, so it's not going to be exact, but for the purpose of this, it is. I have 1, 2, 3, 4 pieces. So how many pieces does it take to make a whole? 4. So what unit are we in? What did we partition this into? 4ths. So this one would be 4ths. Like that. And you can partition multiple things as such. Now, instead of drawing a picture and then you telling me what is it being partitioned into, I could do the opposite. I could give you a shape and then ask you to make 4 equal parts to this. So I'll just start with a basic one. And I'll say, let's actually make it 3 equal parts. So if I were to do this, are those 3 equal parts? No, they're not. Not going to work that way. There are a couple of ways you could potentially do this, but there are a lot of ways that it will not work. If I did this, that's not going to work either. Because these 2 pieces might be equal to each other, but the one over here is not. So, for my brain just likes to go like that. But technically, you could go across both of them and make 3 equal pieces, but for my brain, I'm going to do this. This would be in thirds. Because how many pieces does it take to make a whole? 1, 2, 3. So I'm in thirds. Another way you could do this is if I had a line between 2 points, like a number line. And remember, when we did clocks, we could do these like 5, 10, 15, 20 all the way up. So basically, you're doing the same thing. I have this whole line, and I need to make 3 parts on it. So you can just do that. Once again, assuming I've done this perfectly, these should equal the exact same. So this would be 1/3, 2/3, 3/3 if we added all them up together. And you can take it even a step further and have a circle. Let me try to get as close to a perfect circle as possible. Not very plausible when drawing yourself, but we're going to go with it. So I have a circle, and for the purpose of this, we're saying it's a perfect circle. I know it's not, but we're going to say it is. And thirds. If I was to cut this up into thirds, I'll use my idea from up here, and I'll just cut across straight down. Are those pieces equal? Unfortunately, no. If I was to take this piece and hold it over here, this middle piece would be larger than this one. And same thing, this piece is larger than that one. So that one's not going to quite work that way. I could try doing it this direction. But you run into the same problem with this one. Still running into the exact same problem. So it might be a kind of an easy way out here just to go, oh, this one can't be cut evenly. You can't do that. But circles play an interesting role here. What if I found the center of it right there and did this? Now, once again, it's not visually 100% perfect, but dividing it up in this direction, we could arguably say all 3 of these pieces are equal to each other. So this circle is cut into 3 equal parts, or it is partitioned into 3 equal parts. So that's kind of what the goal of today is recognizing, being able to look at something and say, oh, it's cut up into this many pieces, so it's 8 pieces, so we're in eighths. Or it's cut up into 7 pieces, so we're in sevenths. Or 6 pieces, so sixths. Or 2 pieces, which is the weird one, which is halves. But that's kind of the idea. Or being able to take a shape and then equally dividing it into equal parts. Just kind of keep that in mind. That's our goal for this one. Hopefully this made sense. Hopefully you learned something from it. And I hope you guys have a great day.